Cell delay is a function of input slew and load. Output slew is a function of input slew and load. Net delay is a function of drive strength, input slew and load. Use actual slew from A to compute TR1 going into the AND gate input pin. Use TR1 to calculate cell delay and compute the output slew TR2. Use TR2 to compute net delay and slew TR3 going into the NOR gate. Use TR3 to compute NOR gate delay and output slew TR4. Use TR4 to compute net delay and slew TR5 going into the XOR gate. Use slew TR5 to compute XOR delay and compute output slew TR6. Same procedure till the endpoint. The point to note here is that the actual slew in the path is propagated across the nodes in the path. Slew from nodes outside of the path are not taken into account. To compute the worst delay to the endpoint, 16 path delays need to be computed. Delay for same cell and net arcs computed multiple times as part of different timing paths. Each time potentially with different actual slews. Add a method to the output nodes, to propagate worst slew coming into that. So, the output slew is computed not on per path basis. But the worst slew from its input nodes is propagated out. One for rise and one for fall. This is not path dependent. For the AND gate, 30 ps is propagated to the output pin. Delay arcs for the AND gate are still computed with 10 ps and 30 ps. It's just that the output slew is computed from the worst slew, 30 ps. Let's assume that to be 45 ps for now. NOR gate cell delay are computed using 45 ps and 80 ps. But 80 ps is propagated outside. Let's say that results in 95 ps slew on one of the XOR inputs. Now, XOR delays are computed using 95 ps and 100 ps. But 100 ps is propagated out. In this case, every net delay is computed once for rise and once for fall. And similarly cell delay not computed for all possible slews coming into it, while tracing different paths. But just the worst slew which was propagated to it. This results in lesser number of cell and net delay calculations. For ease of understanding, let's assume that all net delays to and from the ports to be 0. And, the rise and fall slews are same. Also, cell rise and fall delays are same. This is simplify the calculations. Let's see how the delay and slews are calculated in GBA mode. Let's look at GBA delay from inputs to output. And also, to the endpoint, Y. But this comes with additional pessimism. Take a look at this example. Arrival time at one of the inputs is 100 ps and the other one is 10 ps. But the pin with worse arrival has far better slew than the other one. But the output slew of the AND gate, in turn, the net delay and the slew going into the inverter will be calculated using the worst slew. Net delay and inverter delay computed in GBA mode will be conservative. And will increase the arrival time, or max delay through the first pin of the AND gate. But if you do PBA, this pessimism will go away.